Okay guys, in this video I'm going to be showing you how to create the Arbor Press, new standard IPT. The first part that we're going to be creating is the base, so let's go ahead and get started on the XZ plane. Pay attention to how it turns. Make sure that you rotate it so that way we're looking at the top as so. First thing that we're going to do is create a square and then add some cutouts. Oops. All I'm doing is creating lines here that are angled, not attaching them to anything, adding another square here, as well as a slot. I'm going to go to the rectangle pull down, click on slot, center to center, make a line, and create a slot. Once you have all of this, we can go ahead and start dimensioning. The first thing that we need to add is our overall width from left to right, which is going to be 3.5 inches long. The next thing that we're adding is this dimension here. This is 2.5. And the same thing down here, 2.5. Our overall depth from front to back, this is 2.875. And from the center of our slot to our back face, this is 1.438. The size of our cutout here, this is going to be 1.01 inches, and we are going to position it by clicking here and here, and this will be 0.938. Our angled line is going to be 0.69, and from this point to our front face, that should be 2.19. The next dimension that we need to add is the location of this arc. So we're going to click on this line and pay attention to how, or to what, pay attention to the green dot that pops up. When it pops up, click there, and this is going to be 0.812. And then the size of our slot is 0.625. Once you have all of that, we're going to lock it into place by going to the coincident constraint, finding the center point here, and locking it into the origin. And you can see that we did forget one dimension, which happens to be this cutout right here. And this is just going to line up with our point right there. So we're going to use our vertical constraint. Click there, and everything is properly placed. Go ahead and finish your sketch so that we can extrude this, and we are extruding this by 1 inch. We next need to add a few holes. So the first hole that we're going to add is on this face. And we're just going to put a point right there and dimension it from our left, or from the top to the point, and this is 1.062, and click finish. Click on the hole function and it automatically selects it, and we are going to be creating a standard hole, simple hole, that has a depth of 0.562 and a diameter of 0.255. Okay. Our last hole that we need to add is right here on this face, so click there. All I'm going to do to make sure that I am properly located is I'm going to project my geometry, draw a line from corner to corner and put a point right in the middle of this line. This is the fastest, easiest way to accurately get the center mark, and put a hole, and this hole is going to be tapped. It's going to be a 3/8 hole, so go to 0.375, and it is 3/8 16 UNC, and it has a depth of 0.75. Okay, once you have that, you can go, oh, we just need to add some chamfers. We're not quite done. Chamfers on these corners, and click, oh, we need to change the distance, 0.06, and we need to change the material to SAE 1020, which happens to be a steel. So go to the materials pull down, find steel, and it is a mild steel. Once you have that, go ahead and save this. We are going to be making a new folder, and this will be called the Arbor Press. And this is part 1, base. Part number 3 is another standard IAM. We're going to be creating this on the XZ plane. Rotate it so that way we're looking at it correctly. And we're going to be making 2 circles, 1 and 2. Our first circle is going to have a diameter of 2 inches, and our inner circle is going to have a diameter of 0.264. Next, we're going to be drawing slots, and these are just going to at our 12, 3, and 9 location. Now we're going to go ahead and start dimensioning these circles, or these slots. Our first slot that we're going to be working on is our 12 o'clock slot. This slot has a diameter of 0.5, and it is located 0.5 from the center. Then we'll move on to our 3 o'clock slot. This is 0.375, and it is located 0.437 from the center. Next, move to our 6 o'clock slot. This is a diameter of 0.25, and it's located 0.625 from the center. And our last slot has a diameter of 0.625. And if this happens, just click and drag it and dimension it to be 0.562 from the center. Last thing that we need to do is make sure that everything is in line with the origin. So go to your vertical constraint, and I'm going to click on my center point of this slot and my origin, and the center point of this slot. Same thing going horizontally, center point to the origin to the center point, and center point to the origin. I'm sorry, origin to the center point, and origin to the center point. Once you have that, go ahead and say OK, and let's extrude this. All we are extruding is what is highlighted in green. Go ahead and click on that, and that has a distance of 0.5. Click OK, and we are going to be adding some chamfers here on both the top and bottom of each wedge. With a distance of 0.06 and say OK. Once you have that, we need to change the material to SAE 1020, which happens to be a steel, a mild steel. So once you have that, go ahead and save this. This is number 3, table. Part number 4, the ball end, standard IPT, and we are going to be creating this on the XY plane. This is an object that we will be revolving. So let's go ahead and work with a circle. Since this is a spherical object, we need to make a circle first and then draw a line from left to right to divide it in half. This will be the axis that we are revolving around. Go ahead and dimension this circle to be 0.562, and then let's add in some cutouts. Switch over to a 2-point rectangle, and we're going to be adding a cutout here and a cutout here. So this So we need to make this point line up with the circle. So go ahead and click on coincident. Click on this point and the circle, and it lines up. And then if it happens to move around like this, don't worry. Just click on the line and reconnect it to the origin. Next thing you need to do is add some dimensions. This, from top to bottom of this rectangle, is going to be 0.375 divided by 2, because we are revolving it around a center axis. If it happens to move again, just reconnect it to the origin. This here, this hole that we'll be putting here, is 0.249 divided by 2, and it has a depth of 0.4. So from here to here, this will be 0.4. So once you have that, this is where the magic happens. We're going to be revolving just this highlighted green area, and it is revolving around the center axis that we made. Okay, as you can see, it is a spherical object. You can rotate your view cube to look at it, and let's go ahead and change the material to SAE 1020, which is steel mild. Go ahead and save. This is number 4, ball end. Part number 6 is a standard IPT. We are going to be revolving this. So you need to draw 2 rectangles that go clear across the origin, like so. I'm going to be clicking on my coincident button, finding the origin, and then finding the center point of both rectangles. The overall length from left to right of this object is 6 inches. And each of these ends has a length of 0.375. Since we locked in the center points, it automatically adjusts it on both sides, so we don't need to do anything over here. Now all we need to do is add our diameters. This is 0.35 divided by 2, and this is 0.249 divided by 2. Once you have that, go ahead and finish your sketch. Click on Revolve and select both rectangles. And the axis that you are revolving around is that bottom line. And then click OK. And there it is. Next, change the material to SAE 1020 steel mild. This is number 6 handle.